Hi everyone, hope you're doing well. Today we're going to go over how to read solubility curves. These are not too bad to read. A lot of times people overthink them and it's easy to get confused. You just have to make sure you're reading your graph correct. And yeah, let's get going. So first, solubility. What is solubility? Solubility is the ability of one substance to dissolve into another substance. So my solute dissolves into the solvent to make a solution. So solubility, it dissolves. Solubility is usually expressed as a rate, and this rate tells us the amount of solute per the amount of solvent. So for example, you'll usually see like this, 36 grams of NaCl divided by or over 100 grams of water at 20 degrees Celsius. That means I've got 36 grams of NaCl, salt, dissolved in 100 grams of water at 20 degrees Celsius. So pretty simple. If I didn't have it written, usually you'll see like an actual division sign like that. Just tells you it's usually more like that. So reviewing from our notes yesterday, factors that affect solubility. Temperature for solid solutes, as temperature goes up, solubility goes up. So the hotter it is, the more you can dissolve. For gases, it's the opposite. As temperature increases, solubility of a gas decreases. And then pressure. Pressure doesn't really affect solid or liquid solutes, but for gases, if you increase the pressure, the gas particles are more soluble. Or if you decrease the pressure, the gas particles are less soluble. This was in our notes yesterday, Henry's law. It says just that. So any solution can fall into one of three categories. It can be saturated, unsaturated, or supersaturated. So a saturated solution is a solution that contains the maximum amount of solute per given amount of solvent at a constant temperature and pressure. It has the maximum amount dissolved. You can't dissolve any more in there. While an unsaturated solution, a solution that contains less solute than the saturated solution. So you can dissolve more in an unsaturated solution. And then a supersaturated solution, a solution that contains more solute than theoretically it can hold at a given temperature. So it's not supposed to have that much dissolved, but it does. If we can ever go back to school, we have a super fun supersaturated lab that we do. You make a supersaturated solution, like rock candies, supersaturated. It has more dissolved than it should. And we'll talk more about those later. But saturated, maximum amount dissolved. Unsaturated can dissolve more. Supersaturated has more than it should have dissolved. And here we go. Again, just reviewing the three types of solutions. And so you know your solution is saturated because no more solute can dissolve. So you add more and it doesn't dissolve. And then supersaturated solutions, yes, they have more dissolved than they should. They're very unstable and they form crystals. Rock candy is a bunch of crystals. It's from a supersaturated solution. And then you know a solution is unsaturated because you put stuff in it and they dissolve. That means you can keep dissolving solute. So this is a solubility curve. A solubility curve is a graph and it shows the maximum amount of solute dissolved, usually just about always in 100 grams of solvent at a specific temperature. And so we're just going to look at this really fast. My x-axis tells me my temperature. My y-axis tells me how many grams of solute are in 100 grams of water at that temperature. And then we have a bunch of solutions. So if I were to read this, we'll look at the Ki, which is yellow. This tells me that at 10 degrees, I can have about 135 grams of potassium iodide dissolved in 100 grams of water at 10 degrees Celsius. And then at 20 degrees Celsius, I can have 145 grams dissolved in there. And I know that because Ki is right here. If I were to look at the solubility curve for NaNO3, let's look right here. Erase that. At 10 degrees Celsius, you're like right here. So that means I can have about 80 grams of sodium nitrate dissolved in 100 grams of water at 10 degrees Celsius. At 40 degrees Celsius, I can have about 105 grams of NaNO3 dissolved in water. Okay, let me erase this so you can actually read that. And so if I dissolved here, this example is about the KNO3, so let me erase that. So if I had 80 grams of KNO3 dissolved in 100 grams of water at 50 degrees Celsius, that is a saturated solution. So let's look. KNO3 at 50 degrees, yes, is right at 80. And so that is a saturated solution because it's on the line. So this graph tells me when a solution is saturated. How much can dissolve when the solution will become saturated. And so this is like a little cheat sheet. You might want to write this down. If I asked you, let's say let's go back to NaNO3, and I said, let's look at 10 degrees. So 10 degrees is right here. Let's say at 10 degrees, I had 60 grams of NaNO3 dissolved. Where does that fall? NaNO3 at 10 degrees is right here at 80. 60 grams is below the line. So that would mean my solution is unsaturated. I can dissolve more because at 10 degrees, it can have 80 grams dissolved. If you have the amount that's on the line, if I had 80 grams dissolved at 10 degrees Celsius and 100 grams of water, my solution is saturated because it's on the line. And let's say I said at 10 degrees Celsius, I had 90 grams and they were all dissolved of NaNO3. My solution would be super saturated because 90 is up here. It's above the line. So this table is, or not this table, this graph, these graphs are extremely important when you're trying to figure out what type of solution you have. And it just depends on where it falls on the line. So we're going to practice figuring out what type of solution we have. So if I have 50 grams of KCl dissolved in 100 grams of water at 50 degrees Celsius, what type of solution is it? So KCl is the green one. Looking at 50 degrees, it is right here, which is about 40 grams. So if I had 50 grams actually dissolved, that is here. That is above my line, so that's a super saturated solution because I have more dissolved than I should. And remember, that's for KCl, so we're just looking at that green line. Let's do another example. If I had 50 grams of NaNO3, so now I'm looking at this line. So if I have 50 grams of it dissolved in 100 grams of water at 30 degrees Celsius, what type of solution is this? So 30 degrees Celsius, NaNO3 is right here. That means it can have 95 grams dissolved. Well, I have 50 grams dissolved. I can dissolve more. That is way down here below the line, so it is unsaturated. You can dissolve more. Next, at 30 degrees Celsius, what is the solubility of KClO3? So this question is just asking how much can you dissolve? Okay, KClO3 is this purple line. So at 30 degrees Celsius, you can have about 10 grams of potassium chlorate dissolved. So to answer this question, I would say 10 grams KClO3 per 100 grams of water. That's the solubility. It might be like 12, but 10 is a perfectly fine answer. 20 would not be correct. 10 to 12 grams could be dissolved at 30 degrees Celsius. And then it's important that if I ask you something like this, you say how much water, because what if you add more water? Can you dissolve more solute? Yes. Okay, and leading into that, our next question. At 45 degrees Celsius, how much ammonium chloride do you need to dissolve in 200 grams of water? Well, my graph tells us how much solute dissolves in 100 grams of water. I want to know about 200 grams of water. So if I double the water, how much solute can I dissolve? Well, let's first figure out just with 100 grams. Okay, so 45 degrees Celsius right here, NH4Cl right here, you can have about, that's not 50, like 48 grams dissolved in 100 grams of water. So if set up a proportion, if there was 200 grams of water, that's times 2, you should be able to dissolve twice as much. Now what is 48 times 2? 96. So if I double the amount of water, I should be able to dissolve twice as much solute. Okay, and another one like that, except this time we're going to look at 70 degrees Celsius, how much KCl do you need to dissolve in 150 grams of water? So a little different. Okay, but first let's just look at KCl. It's the green line. At 70, you can have, it's right here, that's about, I don't know, let's say 47 grams. It's about, I'm not going to be like, oh, I said it was 48, you said it was 47. That's wrong. Somewhere along that. So I can have 47 grams dissolved in 100 grams of water. And I know it's 100 grams of water because that's what my graph says. So if I wanted to figure out how much could dissolve in 150 grams of water, well, what do I multiply 100 by to get to 150? I multiply it by 1.5. 100 times 1.5 is 150. And so if I multiply this by 1.5, 47 times 1.5 is, I have to do that on my calculator, 70.5 grams. That's how much you should be able to dissolve. So reading these solubility curves, they can be a little tricky. You need to make sure that you first are looking at the correct substance. So if I ask you about potassium chlorate, make sure you look at KClO3, not KCl. And then if the amount of solute you have is on the line, it's a saturated solution. If it's under the line, it's unsaturated. You can dissolve more. If I say you have more than you should dissolve, so it's above the line, it's a supersaturated solution. And yeah, you're going to go to Canvas now. There are some practice questions over reading solubility curves. The curve is this curve in the PowerPoint. And so it might be easy to just like take a picture of the questions and then come back to this PowerPoint, have this graph open, and read it off the PowerPoint. It's probably clearer than trying to look at a picture of the graph on your phone. Just a little helpful hint.